All right, so now we can talk about graphs of other trig functions. We recently talked about graphs of sine and cosine. Now we can talk about the other graphs. Some of these graphs come directly from the sine and cosine and others don't. So the first one we're going to talk about is the tangent curve. So if we think about tangent, it's just made up of our sine and cosine. So when we think about this, we know that for our unit circle, that all odd multiples of pi over 2, that our tangent curve is undefined. So that's why we have here at our pi over 2, 3 pi over 2, minus pi over 2, and minus 3 pi over 2 in general is our undefined. That's why we have our asymptotes here. So we're going to be able to figure out points. And the main points we're going to be able to figure out, this point and this point. So these 2 points occur at 1/4 and 3/4 of the way between our asymptotes, will give us a good indication of what our graph looks like. We'll be able to figure out our minus pi over 2 and pi over 2 type of pieces based off of what is inside of our tangent curve. So we'll see different things with different characteristics here. So our characteristics here. So one of the first things to note here is that the period of tangent is different than sine and cosine, as its period is only pi instead of 2 pi. The domain is all real numbers except for odd multiples of pi over 2, as I was just saying with our asymptotes. The range is all real numbers. And we have vertical asymptotes at all odd multiples of pi over 2 because it's not in our domain. An x-intercept occurs midway between each pair of consecutive asymptotes. It's an odd function with origin symmetry. And points on the graph 1/4 and 3/4 of the way between consecutive asymptotes have y-coordinates of -1 and 1 respectively. And this is all if we're talking about our tangent of x. That's not including if we do any shifts or anything or transformations. So we got to keep that in mind whenever we are graphing. So if we move this and we make this a times tangent of bx by the c. So if we have this case right here, we first need to find our asymptotes based off of any shifting we have. So we're going to take whatever is inside of our parentheses here, this bx minus c, we're going to set it greater than negative pi over 2 and less than pi over 2 as our standard. And we're going to figure out what our new asymptotes are, our interval containing 1 period. If we want to know where the asymptotes are going to be at, which is our bounds on that period, we're going to set it equal to each one of them, and we're going to solve. It's the same thing as when we find our interval, we'll be able to see where the asymptotes are at. And then halfway between our consecutive asymptotes is an x-intercept, so that's exactly halfway there. Next, we want to find the points on the graph 1/4 and 3/4 of the way between the consecutive asymptotes. These points have y-coordinates of -a and +a. So notice that instead of 1 and -1, like in the normal tangent, it's going to be whatever, it's going to be -a and +a respectively there. Once we do that, we can finish graphing 1 full period, and we can add additional cycles if we need to. The next thing we can talk about is our cotangent curve. So cotangent curve is basically, it's going to be a little bit of an opposite of our tangent, but we do have a little bit of some differences here that are big differences. Period is still the same at pi. Domain is still all real numbers, except in this case, it's integral multiples of pi. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, etc. The range is still all real numbers. Vertical asymptotes occur at integral multiples of pi. So the previous one we did pi over 2, 3 pi over 2, just the odd multiples. This one is all integer multiples of pi. An x-intercept still occurs midway between each pair of consecutive asymptotes. It's an odd function with origin symmetry. And points on the graph 1/4 and 3/4 of the way between consecutive asymptotes have y coordinates of 1 and -1 respectively. So if we were to extend that now, we're going to work it very similar like we did before. So find two consecutive asymptotes by finding an interval containing one full period. So since it's all integer multiples, that's between 0 and pi now. So 0 less than bx minus c less than pi. A pair of consecutive asymptotes occurs at bx minus c equals 0 and bx minus c equals pi. An x-intercept is halfway between the consecutive asymptotes. And we want to find points on the graph 1/4 and 3/4 of the way between the consecutive asymptotes. And these points will have values of -a and +a respectively. Once we find all that, we should be able to graph one full period of our graph. So if we are looking at this function right here, so if we go back up real quick and we look at just the graph, so this cotangent's normal graph looks like this, going down left to right, like a cubic function, versus tangent goes up like a positive cubic function. Note that tangent is between negative pi over 2 and pi over 2 unless there was a shift, and cotangent is between 0 and pi. So notice here we have all of our tangents. So we know it's some type of tangent because they give that to us. So yes, I know that D is already circled for us as the correct answer, but let's think about things here. So we have the fact that we're going up left to right. That throws out anything that has a negative on our tangent, because if it was a negative tangent, it would look more like our cotangent graph. Now, we are normally have asymptotes at negative pi over 2 and positive pi over 2. So this is normally where my asymptote is. When we move the asymptote to here, which was a shift of just a pi over 2, because now we're at 0 and pi for our answers. So we shifted it pi over 2, which is why it's D instead of A. A would have been a full shift over to pi, a shift of pi instead of pi over 2. So whenever you're looking at different things, we see that if it would have been negative, it's a little bit hard to tell between cotangent and tangent if there is a shift. Just a simple shift of pi over 2 and a negative tangent looks identical to a cotangent. All right, so what are we going to do here now? So we have a tangent graph. So we need to graph this. So first we need to find an interval containing one period. So we need to shift. So we have negative pi over 2 less than 1/2 x less than pi over 2. So we're going to multiply everything by 2. So we get minus pi less than x less than pi. So this is my interval that we're working for one period here. So if I just identify this as minus pi, and this is pi. So that means that my asymptote are in these spots right here. So once we found our asymptotes, we need to identify an x-intercept halfway between the consecutive. So halfway between is going to put me right here. Now, keep in mind, this is a negative. So that means that at 1/4 of the way between them, we're going to be at a positive a. So that's going to be at 1. And then 3/4 of the way, we will be at -1. So once we have these values, we know that our graph, and a little bit hard for me to draw this graph on this right here. So our graph will do something that looks like this right here. It looks very identical to the cotangent, like I told you, because of the negative out there. But in terms of everything else, that's exactly what we would have here. So the next thing that we could look at is which is the correct graph of y equals 1/3 cotangent of 3x. So first, the one that we can eliminate right off the bat is going to be the third one here, because we know that by looking at cotangent has the other way if it's positive. So it has to have a form of the first or the second one. Now, in terms of our cotangent, what we would need to look at here is which one shows halfway between them, because we have 3x, so we have 0 less than 3x less than pi. So therefore 0 less than x less than pi over 3. So we could actually zoom in here. So that is a pi over 3. That is a pi over 3. So our interval is correct. So next thing it tells us is that there's an x-intercept halfway between. Well, if we look at this second one here, so halfway between 0 and pi over 3 would put me right here. But as we can see, we're way up here. So therefore, we can eliminate that one. And that this one is, the first one over here is our graph. So we're just using these characteristics to be able to build this up for us. Now, the next type of graph we could have is our cosecant curve. So first, what we want to do, we want to build the sine curve that corresponds to it. We build out the sine curve, and then at all of the peaks of the sine curve, we have a trough of our new curve where we are at zeros for sine of x. So where sine of x equals 0, we have asymptotes. And so we could actually build these out and draw them in this exact way. Some characteristics of our cosecant curve. Our period is just like sine because it's built off of our sine. So therefore it has a period of 2 pi. The domain is all real numbers except for integral multiples of pi. The range is all real numbers of y such that y is less than or equal to -1 or y is greater than 1. Vertical asymptotes at integral multiples of pi. It is an odd function, so cosecant of -x is equal to minus cosecant of x, and it has origin symmetry. We can also find the secant curve. So first, we're going to build out the cosine curve. This is going to look very similar to our curve here as well. So we would do the exact same thing. We're going to build cosine. Wherever cosine has a peak, Cosecant has a trough. Wherever cosine has a trough, secant will have a peak. And a lot of times we do include these little half pieces here. So just be aware that we do include those with our partial graphs. Some characteristics of our secant curve. It has a period of 2 pi because it's based off of our cosine curve. The domain is all real numbers except for odd multiples of pi over 2. And all real numbers of y such that y is less than or equal to -1 or y greater than or equal to 1. Vertical asymptotes at odd multiples of pi over 2. It is an even function, so secant of negative x is equal to secant of x. It has y-axis symmetry. So if we were to look at this example here, so how can we draw the graph of -2 secant of x plus pi over 2? So the first thing that I would draw is, what does cosine of x plus pi over 2 look like? What does this look like? So we know that for this cosine, we had characteristics that this is a shift right by pi over 2. So if we think about our normal graph of cosine, so cosine of pi over 2, I'm sorry, cosine of 0 is 1. So in this case, because of this -2, so we really want to do -2 cosine of pi over 2, sorry. So here is our -2. So this tells us that so this is just for the normal cosine. So really what we're doing is, what does -2 cosine of x look like? And then we'll worry about this shift in a second. So we know that at 0, we're at 1, so that's at -2. At pi over 2, cosine of pi over 2 is 0. Cosine of pi is going to be -1, so that's going to be at 2. And at minus pi, so minus pi over 2 will put us here. And at minus pi, it puts us here. So in general, our graph looks like this for this function. So now I'm going to shift this and make this -2 cosine x plus pi over 2. So I'm going to shift everything by a factor of pi over 2. So therefore, this will come here. This will come here. That will come here. That becomes there. And that becomes there. So now we're looking at this. And we have this. So all I'm doing is just shifting this. So that way we can kind of see what's happening here. So that would be my -2 cosine of x plus pi over 2. So then if I were to draw this one now, -2 secant of x plus pi over 2, we would literally draw this. So we have our asymptotes. Everywhere there is a 0. So then this graph comes in and does this. This one does this. This one does this. This one does that. And this one does this. So the blue would be our -2 secant of x plus pi over 2. So we're just using our transformation techniques. It is a little bit involved when we start doing this by hand and everything because we got to build up everything. So we're told give the graph of the reciprocal function. So our reciprocal function just simply means -1/3 cosecant x over 3. So our cosecant based off of this right here. So first thing is we would have asymptotes. Everywhere it's a 0. And we know cosecant is just simply our graph that does this right here. So the green and the reds there would represent our new graph. So there's not a lot of work there. We just have to literally fill in what we're given and everything. So in this case right here, which is the correct graph of y equals -2 cosecant of 2 pi x? So first thing we know is that cosecant comes, or -2 cosecant references. So this would be the same similar graph to -2 sine 2 pi x. So when x is 0 or 1, that means that this is going to be sine of 0 or sine of 2 pi, which is still 0. So at 0, we need to be at 0. And we know since it's sine that we start at 0 and either go up or down. So therefore, we can eliminate the first one because we start all the way up here at 2. It's a -2 that's going to correspond here. So that means we're going to go down first. So therefore, we can eliminate the second one and the third graph would be ours. So we have to just kind of make sure that we are following everything and that everything is working right and that we follow our characteristics in order to be able to graph things. And doing it by hand, it is very tedious to make sure that we are following everything correctly and doing all of our characteristics, but it's the same style process that we've been using on everything else.